Good afternoon, question, ma'am. Am I audible? I want to just check the sound settings. Okay.
Can you hear me well?
Yes, I can hear you.
Okay.
Ma'am, will start the session soon.
Yes.
Hello, good afternoon. Yes, Dr. Oleg Feygenson, sir. Shall we start?
Yes, good afternoon. If we are ready, let us get started.
Yes, 1 minute. 1 minute, sir.
Okay.
Good afternoon, everyone. Warm welcome to one and all. Myself, Mrs. Vaishnavi Nole, Assistant Professor in ENTC Department. Welcome our today's guest, Dr. Oleg Feygenson. It's my privilege to introduce our today's speaker. He is a principal engineer at Global Technology Research, Samsung Electronics, Suwon, South Korea. President of the International TRIZ Association, matrix official, innovative researcher with proven ability to identify and solve complex technical problems, excellent interpersonal communication and project management skills, years-long experience of working in international atmosphere, experimental physicist with broad experience in the technology development and process engineering, experienced TRIZ lecturer and facilitator, TRIZ Master certified by International TRIZ Association. We welcome you, sir, for the session, and I request you to please take over the session.
Okay, thank you very much. So can I share my screen and start the presentation?
Yes, yes, sir.
Okay. Do you see my screen now?
Yes, sir.
Okay, perfect. I think it would be helpful if all other mics are muted to the moment, otherwise we have some noise background. Okay, thank you so much. All right, ladies and gentlemen, the topic of my presentation today is about innovations in electronics and software using TRIZ. I'm sure many of you have heard this abbreviation, this acronym, TRIZ. If not, I will explain what it is. The next slide, just a couple of words about me and why I'm talking about this topic. During the introduction, thank you, you have already said that I'm a principal engineer in South Korea with the famous Korean company Samsung Electronics. My full-time job at Samsung is innovation with TRIZ. I work at Value Innovation Program Center, which is a part of Global Technology Research. And what we do in our center, we facilitate, we perform a lot of innovation projects. Plus, we teach Samsung engineers how to apply systematic approach to innovation. And TRIZ is one of such approaches. Also, since 2022, from September 2022, I am a president of the International TRIZ Official Association, which is matrix official. While I will be talking, if any questions arise, please do not hesitate to drop me your questions, or as far as I know, many people will see this lecture in YouTube. That is why they will not have this option with, with writing questions. You may send your questions via emails to the organizers of this event, and I will be more than happy to address your questions afterwards. Okay, this is our outline. I will start with some technologies which are made with TRIZ. I will show you some products that are around us, but we have never thought that they are made with TRIZ. I understand the topic of your conference. We are talking about alternative energy, green energy, and that is why I selected a couple of examples to show you how TRIZ can be applied in these fields. For those of you who are not familiar with TRIZ and have no idea how TRIZ works, I will show you a simple problem that we will solve together at the end of this lecture. Then I will show you briefly what the electronics and software industries nowadays, how they look like, what are the challenges. I will talk a little bit about specifics of TRIZ application for software. And then, of course, specifics of TRIZ application for electronics. I will also show you that with Samsung, we also face these problems with energy, with green energy. We are trying to create efficient technologies in terms of energy consumption. We also worked for some, for batteries for electric vehicles. It is a long story. I don't want to show a lot of details in this presentation. I will briefly mention what was done. And we will finish with some takeaways. All right, let us get started with the first topic. What is made with TRIZ? And the first company which has been using TRIZ for more than 20 years is Hyundai Motors, also in Korea. You probably heard that in 2022, Hyundai Motors made a decision to close a research center for regular vehicle with combustion engine. All efforts are focused on hybrid and electronic vehicles. You know this line of hybrid and electronic vehicles, which is called Ioniq. The reason I'm mentioning that, because in 2022, a great person from Hyundai Motors, my good friend, Korean gentleman, Mr. Jae Young Kim, TRIZ master, he won a prize, a really, really big prize. It is Invention King in Korea 2022. And Mr. Kim got this title because he created a lot of innovations in the area of hybrid vehicles. To be more precise, his research is focused on cooling systems for hybrid and electric vehicles. So definitely TRIZ is used a lot in this industry. Another example, this example is 10 years old. Before my journey with Samsung Electronics, I spent good amount of years, maybe 10 years, with TRIZ consulting company in the United States in Boston, Gen3 Partners. And one of the clients of Gen3 Partners was General Electric, Global Research. Global Research is located in Niskayuna, Albany. They also have, as far as I remember, a facility in Bangalore, India. They used to have facilities in Munich, Germany, in Shanghai. But what I wanted to say that was a huge number of projects about wind turbines, about wind blades. And when you see GE wind turbines, most likely some parts of these turbines are made with TRIZ. For instance, what you see on this picture, that was a TRIZ project. So, the problem was like this. They wanted to capture more energy with a single turbine. In order to do that, they were thinking about new design of a single blade, how to make it wider, how to make it longer, etc. In TRIZ, we have so-called principle, another dimension. And together with GE engineers, we developed this idea. It is so-called air modifying assembly. So instead of modifying the blade in this direction or in this direction, we introduce 3D structure on the blade, and because this is much more developed surface, now the blade can, be more efficient in terms of capturing wind. To continue with energy-saving technologies, green technologies, Owens, Illinois is another good example. Owens, Illinois is the world's largest manufacturer of glass bottles for medicine, for liquors, for beer, for juices, and some other beverages. And as you understand, when you produce a glass bottle, you consume a lot of energy. You need to melt this glass. You need to keep this glass hot until you form the bottle, etc. Then transportation of glass bottles also requires a lot of money because the bottle is much more heavy than a plastic bottle or aluminum can. So it was a big program within this company, Owens Illinois, how to reduce energy consumption within the entire process, from glass melting to bottle transportation. As you can imagine, one of major ideas was how to make bottle light but strong. And there were a number of other projects how to make the glass furnace more energy efficient, etc. So it took us a couple of years. And nowadays, if you go to the supermarket, if you take a bottle and if this bottle is light, and also you can check the glass bottle here near the bottom, if you see those two letters, O and I, almost for sure this bottle contains some TRIZ part. Alright, not only energy consumption, of course. Some consumer product, like these white strips from Procter & Gamble, the first success with TRIZ. Procter & Gamble hired TRIZ consultant, and they were trying to develop a revolutionary new product for teeth whitening. And that's how this product looks like. Chiquita banana, my favorite project because that was the first project where I worked like a project leader. I had my own team, and together we were developing methods of packaging banana. Why should they package banana? What is wrong with banana? Actually, Chiquita understood that they need to win a market competition, and at that time they had only two competitors, Dole and Del Monte. And as you can understand, banana belongs to commodity market. The only way to compete is to reduce cost, right? To reduce price. But Chiquita decided to create an innovative product out of banana. And the innovation was like this. It was decided to create a banana without genetic modification, without preservatives, the banana which can stay ripe and yellow for a long time, for 10 days. As you know, if you take a banana, yellow banana will become a yellow banana with brown spots on the skin in a couple of days. In 4 days, it will be totally brown banana, even though it will be sweet and nice, but the appearance is not good. So what was proposed and developed, you can see the commercial product in this picture, the package which contains a certain amount of oxygen inside, not 20% as we have in the air, but only 5%. But what is interesting, banana itself controls the amount of oxygen inside the package, because banana is breathing. All the time it is breathing. When you put banana in such package, it consumes excessive amount of oxygen, and then it keeps the level of oxygen as low as 5%. And the last example on this slide is this Hilby. It is a fitness bracelet. It is a Russian TRIZ startup. Now they already produced third generation of this fitness bracelet. And what is a unique feature of this device? Actually, it can measure your calorie intake automatically. Not like with my Samsung watch, where I need to put the calories intake. Not like with any other device. This smart device can estimate how much calories you consume based on some algorithms, based on your pulse, based on your heart rate, etc. Okay, I should spend all our time talking about only products that are made with TRIZ, but the bottom line with this slide is there are many products which we see in our daily life, and those products are made with trees. Talking about green energy and alternative energy, definitely trees was applied there, and nowadays we also have projects where we use trees for that. Alright, let me move to the next topic. As I promised, warm up problem. It is needed to attract your attention. It is needed to make you think about this problem your usual way, your engineering way. That's how we all were trained in universities. When we see the problem, we have some common approaches for solving problems. Later today, I will show you another approach, TRIZ approach. Okay, so what you see in this picture is a very simple system. This system is for corrosion test. You have a cubic metal sample and you need to estimate corrosion rate of this metal. How it is done? They have a special container, platinum container. It is not big, it's maybe like a, a regular cup, for coffee cup, this size. They put sample inside of this container and then they add acid. They keep this sample in the acid for a certain amount of time, for the certain temperature, and then they take it away, wash the sample, and they measure its weight. Yeah, they measure the weight before they putting the sample into the container and after. So the difference gives you corrosion rate. Very simple system, very easy. However, the problem is that the container is made of platinum. Why platinum? Because platinum is a very resistant metal. So it can sustain against any acid. That is why only platinum is acceptable in the lab. Now imagine you have a number of samples, not a single sample, but many samples. How can you test them with a single container? Well, the only way is to test them sequentially, one by one. As you can imagine, testing time is, is really high. And the problem is how to decrease testing time significantly, but we cannot afford more platinum containers. So you understand the problem. It is a really simple problem. Moreover, that is the real problem which was solved long ago in 1970s during one of the TRIZ seminars in the Soviet Union. Okay, I will show you the solution, but now try to solve this problem. We all have many ideas, so apply your intuition, your chemical knowledge, your geometrical knowledge, whatever, and try to solve it. Now it's time to talk about TRIZ. What is TRIZ? Actually, TRIZ stands for Theory of Inventive Problem Solving. You may ask me, if it is theory for inventing problem solving, why it is TRIZ? Why it is not TIPS? Why it is not TIPS? Well, the story is very simple. TRIZ is a Russian methodology, and when it moved from Russia to the United States, the first intention was to call it TIPS, TIPS. But you know what TIPS means, right? It's something which you give it to a cashier in the restaurant or in a taxi driver. That is why the decision was made to keep Russian letters here, and in Russian it sounds like теория решения изобретательских задач. So it is TRIZ. This gentleman is Genrich Altschuler, the founder of TRIZ. When he was very young, only 19 years old, he got a dream. He wanted to develop a science which can make people more creative, more innovative. The idea behind creating this science was quite simple. If we can teach mathematics, if we can teach physics, chemistry, other disciplines, why can't we teach creativity. And this gentleman dedicated all his life to creating this theory. And nowadays, TRIZ exists like a science of systematic innovation. Alright, I have said science of systematic innovation. I decided to look for the definition, what the systematic innovation is. I opened Google, I put exactly what I wanted to find, definition of systematic innovation, and I got 121,000 million of results. What does that mean? In my opinion, that means that, people do not have a common definition of innovation. That is why let me spend some time and illustrate you what we, TRIZ people, understand by this term, by innovation. First of all, when we try to create innovation, we usually consider a number of ideas. And by the way, innovation is not necessarily invention. In any area, it could be electric vehicles, it could be glass bottles, whatever. You have some known ideas, but you may find a new application for those ideas, and that will be an innovation. So innovation, it is an idea which you can commercialize in a way. All right, coming back to this equation. When we are working on innovation project, we generate number of ideas, thousands of ideas sometimes. And only one of those ideas is the idea we need. I believe you agree with me. This value of innovation process is really low. This is something what we need to improve. The ideal value would look like this. We have one idea and this is the idea, right? Of course, this is ideal value. In our real life, we cannot approach this, we cannot achieve this ideal value. However, we can get close to this ideal value. When I look to these two simple, very simple equations, I make a conclusion. Generating ideas is easy. All of us generate ideas. We love idea generation process, but finding the best ideas, that requires effort. And then I like this analogy of systematic approach. So I showed you this, dramatic picture. We have low value. We would like to increase this value. And the term systematic sounds to be correct. So what is a systematic approach? And the good example is GPS innovation. Okay, so this red dot is my house in South Korea, close to Suwon city. And for whatever reason, I need to approach Mokpo. Mokpo is the city of the south of Korea. What can I do? I can say, okay, bye, I need to go. And I will start moving randomly. And sooner or later, I will find this city. It may take me a couple of years, but I will find it. Well, Korea is not that big country, plus it is surrounded by seas, and also the North Korea is on the top. So I have no other choice. Sooner or later, I will find Mokpo city. I may use a tool, which is a GPS navigator. And this GPS navigator will guide me through the best available roads. So instead of doing this trial and errors, I will know exactly where to go. But I selected a bicycle. And that will take me more than 1 day. That will take me 25 hours something. Now I can choose another tool, more efficient tool. Same GPS navigation, but I choose my car. And then it will take me only 4 hours, 30 minutes. Why I love this analogy? First of all, we need to have a direction. So when we generate ideas in our projects, we should focus on the ideas which we need. And second, we need to have right tools to develop these ideas. And this is exactly what modern TRIZ offers us. We have a very clear roadmap. We start with problem identification. That's what I told you. We need to analyze our system, at the deepest level possible to understand which idea is needed, which idea will be the idea. And we have a number of tools. We have function analysis, cause and effect chain analysis, etc., etc. Then we apply problem-solving tools for the key problems. We finish this identification stage with a list of key problems. Also, a big variety of different tools can be applied to develop innovative solution. And the last stage, the last step is a concept substantiation. Well, of course, at the end we have a number of ideas. We need to provide reasons to believe that this idea is better than that idea. We need to substantiate them by means of modeling, simulation, and also we have TRIZ tools that help us with ideas substantiation. In this slide, I would like to show you some typical projects that we perform with TRIZ. Of course, it is used a lot for new product development. Again, in any industry. I showed you the very first example with Hyundai Motors. They do NPD projects a lot, and they use TRIZ a lot. Product and process improvement. In my experience with Samsung Electronics, that is about 50% of my projects with Samsung about product and process improvement. Cost reduction, failure anticipation. Of course, we use TRIZ for that. IP strategy, very important type of project where TRIZ can help a lot, especially for patent circumvention. In a few words, imagine you would like to produce a new system or a new product, but you found out that your competitor or your competitors have a number of patents which kind of prevent you from implementing your ideas. Well, there are legal ways how to deal with that. I know that in India, many companies which are specialized on development of IP strategies, which is very good. In TRIZ, we have our own way. We apply a technique which is called trimming. Trimming allows us to remove some components from the system, but preserve the system functionality. And if we do that with the system, we create a new generation of the system. We invent a new system, and that is why we are not limited by the previous patents any longer. So it is a very brief explanation. Of course, it is a long story, not for this seminar. Technology forecasting, technology road mapping, landscaping, adjacent market identification. So all kind of projects can be performed with TRIZ. Let me explain why and how TRIZ works. As soon as I said it is a scientific discipline, every scientific discipline works the same way. We start with our problem. Then we build a model of the problem. Then we apply some tools, scientific tools, and we generate a model of solution. And then we interpret this model as a specific solution, and we have the solution of our initial problem. Let me give you a very simple example. Well-known scientific discipline, mathematics. And let's say I have a specific problem. I'm sitting in my office and there are 20 rooms on the floor, and there are some number of people, and I need my task, my specific problem is to count the number of people. What can I do? I can say, excuse me, ladies and gentlemen, I need to perform my task. And I will go outside and I will start, coming from one room to another and counting people like 1, 2, 3. And in 10 or 15 minutes, I will find my specific solution, right? I will jump from specific problem to specific solution just right away. But it will take me some time, at least 10 minutes. It will take me some additional efforts, and it will bring some inconvenience for you because I will need to interrupt my presentation. I can do it another way. Instead of jumping from the specific problem to the specific solution, I can build a model of my problem. Okay, 20 rooms, 10 people in each room. This is the model, 20, 10. So then I have mathematics. I know that multiplication will give me the result. 20 multiplied by 10 will give me 200. And this is the model of my solution. Why it is model? Because mathematics doesn't tell me if it is 200 apple, dog, people. So I need to interpret it to the specific solution. That's how TRIZ works as any scientific discipline. And everywhere we have tools. When we model the problem, we have problem modeling tools. When we're solving the problem, we have problem solving tools. So yeah, that's how it works. A couple of words how TRIZ is used in big corporations. Once my good friend Dr. Robert Adunka, who introduced TRIZ to Siemens long ago, he said that TRIZ is adopted at Siemens and helps to decrease implementation risks. A very nice area of application. Definitely when you do something, when you introduce new products, that would be nice to decrease implementation risks. Another TRIZ guru, TRIZ leader who used to work for Intel, he said that TRIZ is Intel's innovation platform for 21st century. And by the way, Intel is a unique company which introduced TRIZ at all levels, at manufacturing, in R&D, and even in software department. Later today, I will show you how they use TRIZ for software. Not only high-tech companies, not only Samsung, GE, Siemens, Intel, but many other companies around the globe are using TRIZ. And a good example is Wrigley, the chewing gum company, which is now a part of Mars, bigger company. In 2008, they hired Gen 3 partners to conduct a couple of trainings, TRIZ seminars in the research center in Chicago, United States. And those trainings were very successful. That is why Wrigley said, okay, let us establish the training program and also let us have projects. So actually they wanted to teach their own engineers, but they understood in order to learn something, you need to do something. That is why we worked together with them. We were doing projects, we were explaining how we do these projects, and together we run some sessions where we discussed outcomes of the project. And the huge training program was in Guangzhou and Shanghai in China. Can you imagine that in China they have a huge facility, the world's largest chewing gum factory, and the chewing gum they produce is already really cheap. However, the request was for the cost reduction and process improvement. And with TRIZ we analyzed every single process in the manufacturing line and we understood how to decrease cost. Of course, Samsung. Of course, I can't skip this article. Maybe some of you are familiar with it. It is not very new article. It is published 10 years ago, 2013. However, we do not have many articles with numbers. Plus, this article is published by Forbes. And the article is about TRIZ at Samsung. It explains how TRIZ was introduced to Samsung by Russian engineers at the beginning of 2000s, at the beginning of this century. And it explains that within the first projects with TRIZ, Samsung was able to save over 100 million US dollars. Not only Samsung and other companies, many other companies now are using TRIZ. What should I say? That in India, I know for sure that Tata company is using TRIZ, Mahindra also using TRIZ, and nowadays the exponential growth of TRIZ application we can observe in China. All major Chinese companies, by the way, including Goldwind, Chinese companies, which is famous for wind blades, they internalize TRIZ and use it a lot for create effective, efficient wind turbines. Okay, that was about trees. Let us get back to the problem I gave you at the beginning. I know, I'm sure that many of you have your own ideas. Usually when we have interactive session, people propose the following ideas. Okay, let us make the sample smaller, then you can make kind of segmented container and put number of samples. Unfortunately, it doesn't work because of contamination of one metal by another metal. Some people say, why do we need platinum container? Let us use nickel instead and we can apply a thin layer of platinum. Probably, but no, this idea was rejected by the client. The other people say increase temperature. At higher temperature, the reaction rate is higher and then you will spend less time for testing a single sample. Once again, I understand these ideas may work, but they were rejected by the client. So, my point is, the normal engineers who are graduated by good universities in India, Russia, United States, doesn't matter. They have the known ways how to deal with these kind of problems. We are trying all variants which we learned during our chemistry classes, during our electrochemistry classes, etc. But let us try to think in a TRIZ way. First of all, we need to formulate a problem. In TRIZ, we call it contradiction. Okay? So it sounds like that. If there are many platinum containers, then the test time of multiple samples is short. But the equipment cost is very high, unaffordable. So TRIZ approach is like this. If we don't like a component in the system, we are not trying to improve this component. We are not trying to make a container better. Okay, this container seems to be guilty. It is expensive. We have only one container. What if we have no container at all? If you think about that, we do not need containers. We need functions of containers, right? And what is the function, or what are the functions of the platinum container? Actually, only two functions. Platinum container holds metal sample, right? It is inside of the container, and also the platinum container holds the acid inside. If there is no container, what else can hold acid and sample? And the best approach is to use what is available in the system. It is better if we can teach one of the remaining components how to perform a function of the trimmed component. As you can see, we do not have many options. We have only two components, acid and sample. So, TRIZ way of solving problems, we need to delegate useful functions to the remaining components. The first idea which was developed, let us use a frozen acid and the metal sample will be inside. Well, theoretically it looks doable. We can freeze the acid. We can put the metal inside, but if you think about that, we need to keep this frozen acid somewhere, right? We need to put somehow the sample inside. Plus, at low temperature, if the acid is frozen, the reaction rate is really dramatically low, so this tasting time will take forever. What about this idea? What if we teach a metal sample to perform a function of the container? So we drill a hole, right? This cavity inside of the sample, and we put acid inside of this cavity. Okay? So now we do not need any container at all. And testing time, we don't care about testing time. We do not care about how many samples we can test at the same time. Any amount of samples can be tested with this new approach. This is the TRIZ way of thinking. So First, we need to understand where the conflict is, where is the contradiction. Then, instead of improving something, we are trying to, to find a new approach. And one example which I have shown you is trimming. We do not like a container. Let us get rid of this container. Okay. Same way, by the way, we solved many problems with wind blades. We kind of reformulated the way which people usually model the problem. I remember there were a lot of projects about assembling and maintenance of wind blades. There were a number of projects about batteries for electromotives. With Samsung, as I mentioned, we had a project about a battery for electric vehicles. Samsung SDI is the division which produces batteries. And of course, the problem of battery utilization is a huge problem, right? That's something which should be solved. And we had a number of projects using TRIZ, and we found a number of good solutions how to find other applications for battery after the service life is finished. Okay, a brief overview of electronic and software industries. As all of you know, we live in the industry 4.0, which means that it is ongoing automation of traditional manufacturing. Besides that, we have large-scale machine-to-machine communication and the Internet of Things. But according to some research, now we are entering the industry 5.0. So what that means? That means that man and machines will work together. As soon as we understand that we will work together with machines, that's out of question that electronics and software, they play critically important role in the industry 4.0 and even more important role now. So that is why a lot of innovation efforts are focused in software and electronics. And by the way, when we are talking about software, again, I'm trying to make a link to the topic of your conference. I see a lot of approaches how to use software in order to minimize waste, in order to improve energy efficiency, in order to improve life of the battery inside the phone. By the way, also we use software for that. Okay. If we are talking about software specifically, nowadays it is developing more rapidly than ever before. So if you open statistics of startups which have been opened recently, software is the primary startups. Okay. Why is that? First of all, innovations in software do not require huge investment. So theoretically, you can do that using your laptop, your knowledge. But software cannot exist without electronics. And electronics can be divided in 4 major categories: components, telecommunication, consumer electronics, and industrial electronics. Semiconductor industry is a huge part of electronic sensor. Samsung Electronics is the leader in memory chips, and also we produce AP, application processor chips. And in this slide, I would like to make the simple conclusion that software industry cannot exist without semiconductor industry, because semiconductor industry produce brains for software, but software makes these brains work. I will show you a couple of examples where TRIZ was used for software and then for electronics. I mentioned Intel, this company which introduced TRIZ at different levels, from manufacturing to R&D and even for software. In St. Petersburg, Russia, that was a branch of Intel. And in this office only, it was not a big office, maybe 100, maybe 150 people, I do not remember exactly. And these people were software engineers. And they heard about TRIZ success in manufacturing. They heard about TRIZ success in R&D, and they asked our company to conduct a seminar, TRIZ seminar, 4 days seminar about TRIZ in Russian office of Intel. That was a little bit, tricky task for us because TRIZ was developed for mechanical, electronic system, not for software, for something, solid, for some technical systems, not software systems. However, we were brave enough and we decided to run this test, this experiment. So we introduced exactly the same training slides which we used with General Electric, with Intel manufacturing division, and every single day, at the end of the training day, we asked the question, what is your opinion? Is TRIZ applicable for software? And this is the statistic. So, first day, when we were talking about problem identification, when we were showing some tools that help to define problems, most of people said yes. 60% said yes, 40% said partially. It is applicable, but some adaptation is required. Nobody said no, which is good. And by the way, all other days, results were the same. Nobody said no. As you can see, some problem-solving tools were not really appreciated by software guys. They said, no, that might be difficult to use your approach of trimming, so we do not know how to delegate functions, etc. However, again, the main conclusion was that TRIZ is applicable for software, but some adaptation is required. Out of 20 people in the class, and these people were very experienced software engineers, nobody said no. This is the list of TRIZ tools which they liked a lot. Basically, they liked engineering and physical contradictions. This is a TRIZ way of modeling a problem. I will not spend our time now because, it's not the topic of this seminar. They have they also said that feature transfer is a good technique. Feature transfer is when you combine two systems with opposite pair of advantages and disadvantages, and you create a hybrid, a system which has only advantages and it has no disadvantages. Function-oriented search is a very interesting approach when instead of inventing something from scratch, you look in other industries and you are trying to find how this problem is solved in the other industry. What is interesting for software engineers, it is difficult to look, let's say, in manufacturing, it is difficult to look in production technologies. However, they found a lot of interesting algorithms in nature. For example, when ants moving some parts, they have some algorithms which are not obvious for engineers. So, without any details, they were impressed with function-oriented search. They researched nature as a leading area and found many interesting ideas from there. Other tools like function analysis and trimming and substance field modeling, they were not really appreciated, but still they were not rejected. Some people liked them, some people didn't like them, but the conclusion was good tools. We may apply them after some adaptation. And the biggest challenge when we apply TRIZ to software is that we apply it not for material objects, not for technical system, but for data and information. And data and information, these are unique things. Data, by the way, it is an unstructured information, while information is data which is accurate and timely, specific, organized for a purpose, and presented within a context. So we need to distinguish between data and information first. Then we need to understand that information is not like a material object. For example, if I take my book, I split it in two parts, then I will not have enough knowledge. And if I give the second half to you, you will have not enough knowledge. But if I read the book and then I explain what is in the book, what is written in the book, then both of us have the same information. So the more I share information, the more information we have. That is an interesting property of information. Why I'm talking about that? Because these are unique things for applying TRIZ in software. People in the past, when they didn't apply TRIZ for software, never considered that. And I will show you one project which we performed with my colleagues from Russia for a company which is called Docs in Box. This company is for automation flows of documents in restaurants. I'll explain you. Let's say there are many restaurants in city like, I don't know, New Delhi or Dubai or Moscow. And there are a lot of suppliers of food which offer the food, beef or chicken, lamb, rice, tomato, different kinds of food to the restaurants. And the main idea of this company, Docs in Box, is to make everything automatic. You have a list of suppliers, you have a list of restaurants, and they can negotiate in so-called online marketplace, and it makes it possible for suppliers to sell the food better without losing food, and at the same time it allows the restaurant to select the best available product on the market. We developed the model to understand why this marketplace is needed, what is the main function, what is the purpose of this system. And this is not a TRIZ way. We said that main function of the marketplace is to generate information. So people were thinking about suppliers, about some storage facilities, about delivery trucks or motor rollers. They were thinking about material objects and how to improve this system at the material level. As soon as we moved at the level of software, like database, price list. What is a price list? It is just some information. And we understood all functions which are between these components. So we were able to develop some very nice, feasible, fruitful ideas how to improve this marketplace and make it attractive for both, for restaurants and for food suppliers. And that was done for city of Dubai. Okay, let us get back to electronics. As I said, with Samsung, we have many projects about semiconductors. And specifically, when we are talking about semiconductors, it is always a matter of being green. Because in semiconductors, you have a lot of chemical substances which are really dangerous for the environment. One of the projects we performed was about photolithography process. Then when they produce microprocessors, there are many operations with a semiconductor wafer. And one of the process, very important process, is called photolithography. And one step when you apply photoresist on the surface of the wafer, okay? And the consumption of this photoresist is excessive. What was understood that we used twice more photoresist that it is needed for the actual manufacturing process, which means the process is not optimized, which means we have a lot of wastes. If we have wastes, not only photoresist, but also electrical energy, we're also wasting that. We are wasting time for maintenance. We are wasting a lot of other things, including, effort from people. And the idea of that project was to reduce amount of photoresist in 50%. And we achieved those results together with engineers. It is also important, before I move to the next example, it is also important to understand that TRIZ expert cannot be an expert in everything. So my background is plasma physics. I have PhD in plasma physics, but I showed you examples with bananas. I showed you examples with chewing gum, with glass bottles. How could I be an expert in every single field? No way. Nowadays, I am an expert in trees. And when I do my trees project, together with my team or as an independent consultant, I always use expertise, subject matter knowledge of the experts in the field. That is important to understand. If some trees consultant tell you, we can solve any problem, do not trust them. They cannot solve any problem without subject matter experts. This is very important to understand. I mentioned function-oriented search, and I said it is not really applicable for software. However, it is very, very applicable for electronic industry. In my experience, to be honest, maybe 80% of all ideas nowadays we generate with function-oriented search. That is why I decided to select this tool and very briefly explain how it works. And I'm sure if you are experts in green energy, in automotive, electric vehicles, we will find a way how to apply these tools in your areas. I will show you an example and then I will explain how this approach works. That was 2014, and the problem with Samsung mobile, Samsung smartphones was that a lot of complaints about overheating. Okay, so if you use some applications like Skype or Hangouts, the phone is getting very, very hot. It is not convenient to hold it near your face. Of course, you can burn your ear or your face, but it's simply very inconvenient, especially at summertime when it is hot outside and you have your hot phone. A lot of complaints. Not only Samsung, many companies, all major manufacturers. Apple at that time introduced aluminum case for the iPhone. Sony Xperia introduced heat pipe inside the phone. Can you imagine a heat pipe inside the phone? Why? Just to redistribute heat inside the phone. Okay, we had a team of subject matter experts and we have 3 TRIZ experts. We had meetings every single week and we worked between meetings trying to identify the problem first and then find feasible solutions. And the first idea was developed at the second meeting. If you look at the structure of the smartphone, they have application processor, the brain of the smartphone. And this processor is not big, it is 10 millimeters by 10 millimeters. But this processor generates the all heat which we need to dissipate. Moreover, if you look on the structure of this processor, it has a CPU unit, number of CPU units. And this CPU unit is really teeny tiny thing. It is 1.5 millimeter by 1 millimeter. And this area generates all heat. Then what happens? Semiconductor chip cannot dissipate this heat. It cannot conduct heat because it is not a heat conductor. And the idea was, what if we cover the entire processor with a metal layer? Then metal, as a good heat conductor, will move all heat from CPU and redistribute this heat over the big area, and then by radiation we will dissipate this heat very efficiently. Wonderful, brilliant idea, but how to do that? We started our research. There are many thermal deposition methods like hot gas coating, flame coating, plasma spraying, something else, I do not remember exactly, that was almost 10 years ago. But all these thermal methods, they damage chip. Because when you use thermal methods for deposition, you overheat the chip. And inside the chip, you have multi-layer structure. You have PCB boards, you have some components, and they are connected by soldering. If you heat the chip, then solder will be melted and the chip will be damaged, severely damaged. So thermal deposition methods are not applicable. There are low temperature deposition methods like chemical vapor deposition, physical vapor deposition, but they are very expensive and also the productivity is not enough. So it is time to apply function-oriented search. And function-oriented search is about searching for technologies available in other industries. Okay? And what we need to do, we need to formulate our function first. What function should we solve in order to, so what function should be performed in order to solve our problem? As you can imagine, we are looking for a way to form a metal coating on the semiconductor chip. That is very specific formulation. Let us be more generic. Let us generalize the function. Okay, we need to form a layer on the substrate, any substrate. I'm not talking about semiconductor anymore, any substrate. Then I need to formulate some requirements. No damage, no overheating, quick, not expensive, etc. I kind of create an image of the technology which I will be looking for. Then the most interesting part, we need to identify technologies that perform similar function in so-called leading areas. And here is the typical mistake. As soon as people hear this word, leading, they said, okay, leading areas are electronics, nanotechnologies, what else? Bioscience, something which is new, some technologies which appeared in this century maybe. This is the mistake. We need to focus our effort in the areas where the same function is performed under more challenging conditions, where people know how to perform this function. Okay, so that is very important to understand. We are not looking for modern new industries. We are looking for industries which are function leading areas. And we found such industry. This technology was known in the Soviet Union starting from 1960s, 1970s. And this technology was never used in semiconductor industry. What it was used for, for repairing metal parts of heavy machines. For instance, when you have some frictions between two metal parts, as you can imagine, that will be severe wearing. And disassembling of this machine is a pain in the neck. Somehow you need to form a layer, a new layer, restore the surface with a layer of metal. And so-called technology was called spray. So how it works? They have a substrate, metal parts in this case. They have a supersonic jet of cold gas, room temperature. And they introduce powder into this jet. Well, they have gas heater, but it doesn't mean it heats gas up to, high temperature. It only needs to remove water, remove moisture from the gas. So in this jet, because of the supersonic nozzle, it is here, by the way, supersonic nozzle is here, the particles, metal particles, are accelerated up to 500, sometimes 1,500 meters per second. Can you imagine? This is a huge speed of particles, which means each particle has a very high kinetic energy. When the particle hits the surface, this kinetic energy transforms to a thermal energy. Okay, this is a local melting. Size of particles is really small, it is 40 micron. So the area where the particle is molten is very small. No overheating for the substrate. So we propose the same technology for fabricating of semiconductor chip, AP chip, and cooling this chip with the layer. When I start talking and preparing slides about software and then semiconductor industry, I couldn't avoid this term AI, artificial intelligence, especially nowadays when we have a lot of applications, for example, OpenAI and ChatGPT and many others every day. A lot of artificial intelligence applications are produced and advertised. However, this term is not new. For the first time, this term was coined in 1956. Okay, long ago. But AI hasn't been implemented. Only now AI has been implemented because we have exponential growth of data available. Okay, we have a lot of data in the internet, also a lot of devices, video cameras and card readers. Everything has a lot of data which can be processed as information because we have advanced algorithms now, and software responsible for that. Of course, we have huge advancement in computer power and storage. Remember our first computers? Remember them 20 years ago, 25 years ago, and what we have now? My mobile phone is 10 times smaller, even not 100 times smaller than my first computer, but it's maybe 1,000 times more powerful. Okay, so talking about AI, let me share my thoughts as soon as I start talking about software and electronics and combination. What will be the next step with AI? And especially it is a big problem for TRIZ experts, because very often we can hear from our clients, from our colleagues, that TRIZ will not exist. AI will substitute TRIZ. AI is very creative. It doesn't need to know any methodology. It can analyze data. That's it. So AI will create all innovations around the globe, not TRIZ. In this slide, I collected quotations of some people. First quotation is from Elon Musk when he gave a talk at with Alibaba CEO Jack Ma. That was a World AI conference in Shanghai before COVID, 4 years ago. So according to Elon Musk, AI going to be much more than a smart people. It will be much smarter than the smartest human. Okay, there is another opinion from Mr. John Smith, manager of multimedia and vision at IBM Research. What he said is as follows. He believes that it is easy for AI to come up with something novel, innovative, just randomly, but it is very hard. I would say, even impossible to come up with something that is novel and unexpected and useful. So, why is that? Because AI can work with data which is produced already, with data converted to information, and then with some algorithms developed by a human, it can process this information. My opinion that creativity can be significantly enhanced by TRIZ. So creativity, it is something unique for human. It is not for AI, but AI is a great support. It can take care of other tasks, some routine. I can give you an example. You know, when I was preparing a lot of agendas for different TRIZ seminars, it was not in my home. Of course, it is not allowed to use AI in the office. That was, you probably read an article. It was a really bad situation. But at home, I was preparing some materials for TRIZ official, and I was trying to create the best agenda for different TRIZ trainings. And I used ChatGPT. It helped me a lot with processing of data. Of course, it took me some time for correction, for making schedule more attractive, to changing some words. But in general, it saved a lot of my time. All right, let us move to the conclusions, main takeaway. Once again, with this presentation, I was trying to show you that TRIZ enables maximally effective and rapid innovation in any industry, including green energy, electric vehicle, and all technologies which we face. Talking about electronics and software, they are most rapidly growing area. That is why I choose those two industries and use them as examples and demonstrate to you how we can innovate with TRIZ in these industries. But once again, your industries definitely can be, also improved with TRIZ. Okay, so it is important to understand that TRIZ is not about generating ideas from scratch. We have a very good set of analytical tools, and we also have a wonderful set proven tools of solving problems. Even though some people may not be involved in solving specific technical problems and creating technical innovations, but even managers, even HR people like TRIZ because TRIZ can enhance the overall creativity of the teams of your company. Let me put it on this way. And what I also demonstrated here, that TRIZ is applicable for software. So there are many TRIZ experts that still do not believe in that, but that was my own experience. That was observations of my other colleagues that TRIZ is applicable. As I said at the beginning, if you have questions or any comments, please do not hesitate to send me after the event, because now we do not have this option. And the last thing I would like to show you, this is the conference. TRIZ conference, which will be organized by our TRIZ official association. It will be held in the city of Graz, Austria, from the August 30th to September 2nd. Of course, it is always good to participate conferences online, but for this event we decided to have a hybrid mode, which means those who cannot travel for whatever reason, for financial, for COVID related or whatever, they may participate online. All options are described on the website of our association. Thank you very much for your attention. That is what I wanted to show you today. And yep, I hope that was interesting.
Yes, sir. Yes. Thank you so much, sir.
Yeah.
It was really a knowledgeable session, sir, on TRIZ and how TRIZ can serve both analytical tools and problem-solving tools. I extend my gratitude to Dr. Oleg Feygenson, sir, for guiding us and sharing his valuable time with us. I'm thankful to Sri Maluki Raja Chhatrapati, Honorary Secretary, ESM Society, and all governing council members for their constant support. I extend my gratitude to Dr. D.S. Formane, sir, Principal, ESMS College of Engineering, for motivating us. I'm thankful to Mr. N.P. Mawe, sir, Convener of International Conference on Green Energy 2023, and all other faculty members and participants for their support. We are very much thankful to you, sir, Dr. Oleg, sir.
Yeah, thank you very much. Thank you for the opportunity and good luck. Yeah, stay healthy and safe. Bye-bye.
Bye. Thank you so much, sir. Thank you.